Hi everybody, we are still in problem set 1.1, and we are now in question 22. And we have this still the same drawing, the same figure from page 9. Okay, we have the x-axis, the y-axis, the z-axis. It doesn't matter much, we just need to draw three vectors and to understand that they are in free space. Okay, so we have some vector u, we have some vector v, and we have some vector w. Okay, three different vectors. And now they ask us to shade in the pyramid of combinations something, okay, times u plus something times v plus something times w, okay, c times u, some number, plus d times v, some number times v, plus e, some other number times w, with c and d and e bigger than 0, but their sum less than 1. Okay, in question 20, we said that all the, if we have something, okay, some number c times the blue vector u, that make it longer or short, we go along the u, and we can go and we go also along with another number along the v, and we go with another number along w. So and they limit us that c and d and e altogether can be the most that they can be is 1. Okay, so if we want to know how much along the u, for example, the maximum that we can go along the u, it's 1, because all of them together, c and d and e, are 1. If they are both c and d, I'm sorry, if d and e are both this is 0 and this is 0, then this can be maximum 1. Okay, so the maximum can be when this and this are 0, this can be 1. C plus D plus E must be together 1. So let's say we want to give all the energy, let's say, all the power to U, to C. So only this direction has influence, has effect. So this would be 1 and this 2 would be 0. Or this could be 1 and these 2 can be 0. And so on. This can be 1 and then these 2 would have to be 0, or some other combinations. But you understand that if we go like that, then the pyramid that they call, it's this pyramid that is made of these 3 lines, okay, in space. It's not like we have a pyramid in Egypt, okay? It's not like we have some rectangle base and then some point, and we have a pyramid like this. It's not like that. It's not a pyramid like this. It's a pyramid made of 3 lines. This is made of 4 lines. This pyramid and the point. This is the point, okay? This is the point. And here it has three lines. So it has some triangle in here. And all the lines, well, I drew it in a silly way. Let's draw it like this. Okay, ignore this one. All the lines go to this one point. So it's a pyramid like this, okay? This point here, it's the origin. So what they ask about the pyramid, it's like this. Only standing like this because the origin is in the bottom left corner here, so it's here, okay? And we have a pyramid, and the lines that connect are here. Okay, let's draw them in a dashed form. The line between U and V, the line between W and U. The order doesn't matter, I'm just drawing them. And the line between V and W. Okay, so this is the pyramid. And if we shade it in, let's say, yellow, okay, it's like we make this yellow, so we make this whole thing yellow. So we shade it. Okay, now let's see what else they ask. Okay, and the part that is bigger than 0, it means we can't go into these directions. We can only go from the origin. We can stay at the origin because it can be that C is 0 and D can be equal to 0 and E also. But they can grow up to 1. They can grow up to 1. They can grow up to 1. Okay? So this is what it means, that they're either 0 or positive. They go in this direction, not in this direction. Okay, and mark the vector half of U plus V plus W. Okay, so U plus V plus W would be the vector that is a combination of all of them in the same strength. Okay, let's say we talked about it in question 20, okay, when we had the point where all the medians met. I don't know if you remember, but there was a point, let's say it's here, just I don't know where it was, but it's about, let's say here, for example, and all this was the center of gravity of this triangle, okay, and this point was where all the, if V tries to pull us into this direction and U tries to pull into this direction and W tries to pull in this direction, and they are all in the same strength, okay, so they are not in the same length, okay, so some of them are stronger, okay, but if it's one V and one U and one W, then there is some point, it's not right in the center. If they were exactly in the same length, okay, the vectors were in the same length, so it would be exactly in an equilateral triangle and exactly in the center, but it's not, it's just random vectors. So one of them is longer, so it pulls harder, but so it would be closer to him. But eventually there is one point that is the calculated, okay, the weighted average of their pull, and it is the center of gravity of the triangle. If you want, look at the video of question 20, we explained it better there. And this is, for example, the point, okay, in free space. So this this vector, okay, if we had u plus v plus w, then it would be some vector like that. Let's say something like this. Okay, this is u plus v plus w. Okay, but to here. But if we want a half of it, okay, then it would be, for let's say, for example, I can't draw it really like it should be longer. Then it would be half of it, and this is half of u plus v plus w. Okay, half of u plus v plus w. And that's it. It's in the same direction, but half the length. Okay, this should be like longer, and this is half of this. Inside or outside the pyramid. Okay, when will it be? When can it be outside the pyramid? We showed the example when it's inside the pyramid, okay, when there are normal three vectors. When can it be outside the pyramid? If it is the same as one of the original vectors, u and v and w. If it's like exactly like u, okay, so it's actually outside of the pyramid. You see why? Because it sits exactly, it lies along u, and it's on the wall of the pyramid, but not inside the pyramid. Okay, so let's say if u is here, and v and w, let's say, would be 0. Okay, each of them, v is 0 and w is 0. So this orange line, this u plus v plus w, would actually be u, because v would be 0 and w would be 0. So it would not be inside the pyramid, it would be along the wall of the pyramid. Okay, along the edge, this edge u. And the same with v and w. Okay, it can be that v is 1 and u is 0 and w is 0. So we will have only v, and then it would be along v, and it will not be inside the pyramid, it would be actually outside the pyramid, or let's say more precisely, exactly on the edge of the pyramid. Okay, so I think this is what they mean. So okay, so this was a question. Oh, wait 1 second. Oh, I'm sorry. Here I made a mistake. Okay, this u plus v plus w. I'm just reminding you. Remember, in this question. Okay, I'll do it from the start because it might give you the wrong impression. U plus v plus w. No, it's okay. It's okay, because if it was, I thought this would be right on this triangle, but it's not. If it was a third of u plus v plus w, then it would be on the triangle. But if it's half, it's outside of the triangle. It's longer. Okay, so I did not make a mistake. In the end, it's okay. So so that's it. This was question 22, and thank you.